Hello everyone, today we will talk about ARIMA model. This is a time series model and you can see lots of words here, but don't worry, we will go through it. ARIMA, it means Autoregressive Integrated Moving Average. It is a generalization of the simple autoregressive moving average and added the notion of integration. So that's why it's ARMA plus the I for integration. It is a forecasting method based on the idea that the information in the past value of the time series can alone be used to predict the future values. So we know we can get some information from the history to predict the future. AR autoregressive. It is a model that uses the dependent relationship between an observation and some number of lagged observations. So for example, the stock price today, they may have some relationship with the stock price the day before yesterday. And integrated, the use of differencing of raw observations. For example, subtracting an observation from an observation at the previous time step in order to make the time series stationary. Stationary means like it don't have any trend or seasonality there. For moving average, it's a model that uses the dependency between an observation and a residual error from a moving average model applied to lagged observations. And for the ARIMA model, we know we have three parts, AR, I, and MA. And we also can use P, D, and Q to represent it specifically. P, the number of lag observations included in the model. So we call the lag order. D, the number of times that the raw observations are differenced, and also called the degree of differentiation. Q, the size of the moving average window, also called order of moving average. ARIMA, it means it is a linear regression model that uses its own lag as predictors. Linear regression models, as you know, they work best when the predictors are not correlated and are independent of each other. So how to make a series stationary? The most common approach is to difference it. That is, subtract the previous value from the current value. Sometimes, depending on the complexity of the series, more than one differentiation may be needed. The value of D is the minimum number of differentiations needed to make the series stationary. And if the time series is already stationary, then D equals 0. For P, it's the order of the autoregressive AR term. It refers to the number of lags of Y to be used as predictors. Q is the order of moving average term, MA term. It refers to the number of lagged forecasting errors that should go into the ARIMA model. A pure AR only model is the one where YT depends only on its own lags. For example, the time t value here is a linear regression to the previous -1, -2, and -p plus error. It's a linear regression here. The pure moving average MA model is the one where YT depends on only the lagged forecast errors. For example, here the YT only related to the error terms there. And for the error terms, it is out of the AR model. It's the respective lags. So here you can see like the following formulas, how you get them. So summarized in total, the ARIMA model is the one where the time series are differenced, and once it makes it stationary and combine the AR and MA model, so we get the equation of YT with a relationship of previous values and with some relationship with the error term. So this is the content of today. Thank you for watching. It's about ARIMA, the time series model.